All right, so next we're going to take a look at graphing linear inequalities when they're written in slope-intercept form. Okay, so some of the skills that we're going to need to review and remember from graphing equations in slope-intercept form are using the slope and the y-intercept to graph the boundary line, and also what we reviewed last time about the type of line that we draw. Sometimes it's dashed and sometimes it's solid. We will also need to talk about how to determine which side of the boundary line contains all of the solutions, that half plane that boundary line kind of breaks the coordinate plane into. One side has all the solutions, one side has all the non-solutions. We, of course, want to shade the side that has all of the solutions. So here's just kind of a step-by-step about how do I graph a linear inequality when it's written in slope-intercept form. Now the only difference in these four inequalities here are the inequality symbols. Okay, you've got less than or equal to, greater than, and greater than or equal to. And in each case, we remember that the number in the place of m is going to represent the slope of the line, and the number in the place of b is going to represent the y-intercept of the boundary line. All right, so we're going to start by looking at step one, graphing the boundary line. So the first thing we want to do before we graph the boundary line is identify that slope and the y-intercept from the equation. And again, as a reminder, the slope is in the place of m, and the y-intercept is in the place of b in that inequality. We also need to use the inequality symbol to tell us what type of line to draw. Just like we saw in the previous lesson, we're going to draw a solid line if it's one of the inequalities that has the or equal to line underneath it, because that indicates that all of those solutions on the boundary are also actually solutions to the inequality. However, if the inequality is the ones that are strict inequalities without the line underneath them, we want to draw a dashed line to represent that the ordered pairs along that boundary line are not solutions. So we got to make sure that we have the boundary line in the correct place using the slope and the y-intercept, and also the correct type of line drawn. Okay, so once you have your boundary line in place, now it's time to determine which half plane, so which side of the boundary line, contains all of the ordered pairs that are solutions. So there's actually a couple different ways to do that, but the easiest way to do that when it's in slope-intercept form is to look at the inequality symbol. If your inequality symbol is either one of the greater than symbols, so if it's greater than or equal to, or just the greater than symbol, we're going to shade above the line. So look at the half plane that's above the boundary line and shade that side. Then if it's either of the less than inequality symbols, we shade below the line. So if it's either less than or equal to, or if it's just less than, we shade below the line. And I need to change that. There we go. So we graph the boundary line, making sure it's in the correct location with the y-intercept and the slope. Then we also make sure it's the right type, whether it's solid or dashed. And then we have to make sure that we shade the half plane correctly that has the solutions on it. So let's do an example together. In this example, we are going to graph the inequality written on our left-hand side there. Y is less than 2x minus 4. So as we look at that, we're reminded that this is in slope-intercept form, where it looks like the number in the place of m is 2, so our slope is 2. And the number in the place of b is negative 4. So negative 4 is our y-intercept. Now, in terms of the type of line that we draw and the shading, we look at the inequality symbol less than, and that tells us both of those items. Because it's less than but not equal to, we're going to draw a dashed line. Remember, it's only the or equal to's that we would draw a solid line. Okay, so we have a dashed line that we'll have to draw in just a little bit. And now for the shading, if we have a less than symbol, less than typically means that the y values have to be smaller than anything that's on the boundary line. And if you think about the y-axis, where are the numbers that are smaller? They're going to be as you go down, lower. So because of the less than symbol, we're going to shade below the boundary line. So let's go ahead and begin graphing now that we have everything that we need right up above. We're going to start with the y-intercept because that's how we graph lines. We start at the y-intercept of -4. So on the y-axis, I plot a point right at -4. From there, I want to use my slope, which is 2, to plot the other points. Now keep in mind, when it says the slope is 2, I can think of that as a rise of 2 and a run of 1. Because my rise is positive, I want to go up. And because my run is positive, I want to go to the right. So I count carefully and I rise up 2, and I run to the right 1, and I place another point along my boundary line. I continue doing that in the same way, rise up 2, run to the right 1. I do that as much as I can until I'm all the way to the edge of the graph. So my boundary line is in place. Now I just have to actually draw it. It says to draw a dashed line. So I'm going to cheat here and I'm going to use my line drawing tool so that I know it's straight. That, however, was not straight. Try that again. Use my line drawing tool. I didn't realize I could do that with my writing tool. There we go. Much better that time. A nice straight line that goes through the y-intercept at -4. That's a slope of 2/1, and it's a dashed boundary line that indicates the points on that line, like those red dots, are not actually solutions to this inequality. They're on the boundary line, but they're not solutions. All of the solutions are going to be on either one side or the other. So when we look at this line, it's at an angle, and we can tell that anything above the line would be on this side, because if you look at your line at an angle, what's above it? It's everything over there. Then everything below the line is on this side. And that's actually what we wanted to shade here. We said we want to shade below the line, and it was a dashed line with a slope of 2 and a y-intercept of -4. So all of the ordered pairs, they're in that yellow shaded area, represent solutions to that inequality. You know, it's not a bad idea to just test it out and make sure that those actually are the solutions. So let's pick an ordered pair and just prove that yes, it is in fact a solution. How about, let's try to keep the numbers simple and easy to work with. How about this one in the first quadrant that has an x-coordinate of 4 and a y-coordinate of 1? If I want to test that ordered pair in my inequality, I'm going to use an x value of 4, because that was the x-coordinate of my point, and my y-coordinate is 1. So I just substituted the x is 4 and y is 1. And now I want to just test and see if this is true or false. So 2 times 4 is 8, and 8 minus 4 is 4. I get the inequality that 1 is less than 4, which is, of course, true. So what does that mean because it's true? It just confirms that 4, 1 is, in fact, a solution to this inequality. And then we see that on the graph because it's on the shaded side also. The shading represents all of the solutions, even the ones that contain decimals and fractions. Let's look at number 2. This time we have y is greater than or equal to -1/2 x plus 3. Now we can see in the inequality that -1/2 is the number in front of x, so that represents our slope. Plus 3 is at the end. That represents the y-intercept of +3. When we look at the inequality symbol, greater than or equal to, that tells us the type of line that we draw and whether we shade above or below. The greater than part tells us we want to shade above. The or equal to part tells us we want to draw a solid line. So I have everything in place that we need to begin graphing. I need to start by putting the line in the right place. So we need to begin at the y-intercept of +3. That's one point that we know is on the boundary line because it represents that y-intercept. Other points on the boundary line can be found by using the slope as a way of plotting more points. Because my slope is negative, I'm going to treat this as a rise of -1 and a run of +2. So I'm actually going to go down one spot this time and to the right 2. Down 1, right 2. Looks like I can do that one more time, but then I'm out of space. I can work backwards on this one, so I can draw my boundary line all the way across the graph. And working backwards, I would go up 1 and back to the left 2. See how those all line up? I can actually do that one more time, and at that point, I'm out of space. For my boundary line, it's a solid boundary line because my inequality symbol had the or equal to line underneath it. That implies that all of the ordered pairs that are right on the boundary line are also solutions. So we want to go ahead and draw a straight line. So I'll do arrows on both sides, a solid line, excuse me. So I just leave it on that line style and draw my line to go through those points as best as possible. And notice I extended my line all the way across my graph space. I didn't make it just a short line to go all the way across because it's splitting the entire coordinate plane into two sides, two half planes. One side that has all the solutions, the other side that doesn't have any of the solutions. And of course, the side that has the solutions will be above the line because our inequality was one of the greater than type of inequality symbols. The side that's above this line includes all of the ordered pairs on the upper half of the coordinate plane from that boundary line. So we could always check any one of those ordered pairs. Let's use, again, try to keep it somewhat simple. How about 3, 3? Then we don't have to worry about putting the x in for the y and the y in for the x. We'll just say x and y are both 3s. 3, 3. So plugging 3's into my y coordinate and in for my x coordinate. Oh, maybe I should have picked something else that could multiply by -1/2 better. Oh well, we'll go ahead and do this anyway. -1/2 times 3 is actually -1.5. And then -1.5 plus 3 is positive 1.5. You can double check that on the calculator if you want to just confirm that on your own. But asking us, is that true? Is that ordered pair actually a solution? Well, 3 is greater than 1.5. So this is true. 3 is greater than or equal to 1.5. It just confirms, again, that 3, 3 is a solution. That's why we shaded that upper right-hand side. If we wanted to check a point that's right on the boundary line, we could do that as well. Remember how 2, 2 was right on the boundary line? Let's check and see if that would be a solution to this linear inequality. We substitute a 2 in for x and a 2 in for y, and we get -1/2 times 2, which is -1. And -1 plus 3 is +2. So checking to see if that gives us a solution. Is 2 greater than or equal to 2? Yes, it is. And actually, when you check any of those ordered pairs that are right on the boundary line, what it's going to do is it's going to give you two numbers that are the same when you test it. And because we have that equals to bar in our inequality, it will always be true when it's on the boundary line because a number is equal to itself. If you were to test an ordered pair on the lower side of that line, it would give us a false inequality when we plug that back in. All right, last one we have is y is less than 2/3 x minus 1. If you feel up to it, I encourage you to go ahead and pause the video quick and just jot down what you know about this. Jot down the slope, the y-intercept, the type of line, and the type of shading, and then press play to check to see how you did. So our slope in this one is going to be 2/3, because that's that number in front of x. The y-intercept, of course, is -1 because our inequality ends with the -1. Then we look at the inequality symbol to determine everything else. Because it's less than but not equal to, we want to draw a dashed boundary line. And for the shading, because it's less than and not a greater than, less than we always shade below. Greater than is when we shade above. So we have everything we need to begin graphing. Start by plotting your point at the y-intercept, then use your slope to plot additional points. Because our slope is 2/3, I want to rise 2 and run 3, both in positive directions. So rise up 2 and run to the right 3. Looks like I'm not going to have enough space to do that again, but I can if I go backwards. I go down 2 and to the left 3 to plot an additional point, and it looks like I can't do any more than that. We said that we're going to draw a dashed line, because remember we draw dashed lines if it's either less than or if it's greater than, which we had on this one. So I'm going to grab my line tool, draw dashed with arrows on both sides, and let's see if I can get that to go through the points. There we go. So I have my dashed line that goes all the way across the graph. Last thing we need to do is shade the side that has all the solutions. Either all the solutions are up above the line or below the line, and actually we know they're below the line because we use or we shade below the line anytime we have a less than symbol, or if it's less than or equal to, indicates it's got to be the lower half. Everything down there. And of course, you could double check by testing a point, test an ordered pair just to confirm, but to save time, I'm not going to do that on this one.